Okay, students. Now I was asked to solve 3 separate problems, and in the book on page 264, problems 13, 28, and 53. Okay, so I'm starting with problem number 13, and 13 is asking you to factor. And when you're factoring, you're just rearranging your numbers through division. And how we do that, the first thing I want to do is I want to check to myself, okay, now I got to divide every single term by the same number or variable. So I need to do a check first. Now, if I look at the numbers or the coefficients in both terms, they both have the number 3. So number 3 will be part of my greatest common factor. I'll factor or divide out 3 in a little bit. Now, the second thing I want to check for variables. I see a letter P in my first term. I see a letter P in my second term. So P is also going to be in my factorization. Now, let's see. How many P's would it be? Now, if I look at my exponents, I want to look for the variable that has the lowest exponent possible. In this case, it's 1. See, here, there's no exponent at all. So it looks like my greatest common factor will be 3P. Now, the next step would be to actually divide. So I'm going to divide 3p squared by 3p, and I'm also going to divide 3p by, well, 3p. I mean, that's my greatest common factor, right? So what would actually happen next? So all I'm doing is just rearranging everything. So I found the greatest common factor by understanding that I could divide 3 into both terms. I could also divide p into both terms. Now when I'm physically dividing, nothing's canceling here. I just want to rearrange everything. So when I do that, the first thing I'm going to type is the greatest common factor. That's 3p. Now I'm going to open up some parentheses. Now I'm physically going to divide, and I'm going to write each total in the parentheses separately. In my first term here, I see that 3p squared divided by 3p, well, the 3's would cancel, and one of those p's would cancel. I'd be left with p. And I write a minus sign because I saw a minus sign. Now look at my second term here. The 3's would cancel, the p's would cancel, nothing else left. So I'll just put 1. That's the answer to number 13. Now, to problem number 28 is the same idea. I want to find my greatest common factor, and I got to run a check here. Now, I'll go number by number and letter by letter. I notice that 12, 9, and 6 could all be divided by the number 3. So I'll type in 3. Now, I see an m in all 3 terms, so I'll type m, and I got to look for the exponent here. Let's see, I have an exponent of 5, 4, and 3. 3 is my lowest exponent, so my exponent should be 3. I see n in all 3 terms, so I'll type n. And the lowest exponent I see here, well, there isn't an exponent at all. It must be 1. So now I could type 1 or I could just leave it blank. I think I'll just leave it blank. Okay, so now what I want to do is I want to type in each term and divide by my greatest common factor. So plus, and then another fraction, plus another fraction, and then the numerators should, in each case, should be those original terms that you saw. Fortunately, in this program, I can just paste and cut. And then then the denominator should always be your greatest common factor. So just quick paste and cut, not so bad. Okay, now how am I rearranging everything? Well, since I divided by 3m to the third power times n, I'm going to also have 3m to the third power n times whatever it is that I'm actually dividing here. Now I'll go term by term. See, 12 divided by 3 is 4. M to the 5th power divided by m to the 3rd power. Well, I could just subtract, you know. I could just write this as a subtraction problem, you know, 5 minus 3. 5th power is my numerator, 3rd power is my denominator. Well, 5 minus 3 is 2, so I'll just leave it as 2. And looks like n squared I'm taking away one of those n's, I'll have 1 line left. Now here I have 9 divided by 3, that's 3. m to the 4th power minus m to the 3rd power. Well, now I have 1m power left. And these n's would cancel, so nothing left there. And in my third term, I have 6 divided by 3 is 2. And these n to the 3rd powers are exactly the same. They're just going to cancel. And n to the 2nd power minus n, well, I'm just left with 1n. And that's my problem number 28. Now, problem number 53 is, I'm just checking to see if these are prime or not. And these are prime in as so much as, what? Guess what? I can see it instantly. It's 16. 16 is missing something. It's missing x. But if I do look, they are all multiples of 2. Every single one of these numbers could be multiplied by 2. Or divided by 2. So, you know what? I think I could just divide everything here by 2. I could just do all of this and just say, hey, divide by 2. Well, if that's the case, it's not prime at all. It's composite. So that's the answers to 13, 28, and 53, and I hope that